Some of you have noticed and been confused by the contradiction about when things are due. When I had Master Set 2 in the next week's slot, but posted it'd be due tomorrow, and I thought, okay, I don't know, remember what I was thinking, but I believe I did intend for Master Set 2 to be due next week, and so I changed it in Blackboard. I did not change it on the syllabus, but I changed it in Blackboard. So, as the schedule in the syllabus says, likely to change. So, the Master Set 2 is due next Tuesday. I believe 3 is due next Thursday. I'd have to look again, but it should be, I think I've marked it correctly in not only under the course schedule on Blackboard, but also for the due date within the assignment itself. Questions right now? Okay. Don't forget the course entry assignment. If you have not done it yet, I was meaning to check, I ran out of time. For the pre-course assessment, what we have, or at least the ones I've graded so far, an average of 9.53, plus or minus 5.94, a median of 6 out of, this is out of 30, and then range from lowest to highest. Historical average is 9.1 plus or minus 4.81, so a little bit tighter grouping, slightly smaller average with a median of 8. So this is pre-course. I'm expecting it to be noticeably higher next time. All right, so we talked about vectors last time and addition of vectors, going in from polar to rectangular and back. Let's actually get into some more specific language here. I'll take you through an exercise as we go. So position, and some of this is a repeat of the video, and I apologize for that, but hopefully if you watched the video already, it will be reinforcement, or when you watch the video, that will be reinforcement. But the symbols, I tend to use X a whole lot. In class the other day, I was using S. R is often used, sometimes Y, and sometimes Z. And S, YS. No, not because of arc length. Why would you use S for arc length?
SI?
No, it comes from the Latin. Okay. I believe it's in one of the videos, so you'll learn it that way. R, typically you use R when you're dealing with some sort of radial aspect, that there's some central point that things are moving either away from or towards. X, I do out of habit. I'm trying to break myself of that and use S, because too many students are sort of brainwashed into X, Y. So position is where you are relative to 0. With respect to 0 or the origin, or it depends on how many axes you're working with. So for the sake of this exercise, I'm going to establish 0 to be right here. 0. We'll make it sort of, it's a one-dimensional problem. And I am going to say that to the right is positive. I could equally say to the left is positive, but I've been brainwashed like everyone else. So, is my position positive, negative, or zero?
Positive.
All right, that's the way the game is played. See if we can do that in unison. My position is,
Positive.
all right. And now,
0.
yeah, I'm not worrying about parallax here, so if it looks like I'm hovering around here, then
0.
then we're doing an echo there.
I was off key.
Let's see if we can get a unison on this last one. My position is
Negative.
all right, and this is the way the game is played. So it's where you are relative to 0. If we're dealing with a map, you establish 0 someplace, so we are here. This vector right here would be my initial position. All right. Displacement. And by the way, these are all vector quantities. If I'm asking about position or I'm asking about displacement, immediately you should be thinking vector if there is a direction involved. The symbol for displacement is just very similar to position, except it's change in position, and so we use the capital delta to represent change. So it's change in x or change in s, or it's delta in front of whatever letter you're using for position. So it can be treated mathematically as the change in position, or where you are with respect to the starting point. And you don't necessarily start at 0. If you think about a map, if you think about longitude and latitude of 0 and 0, none of us were born there. I'm betting. I guess it's possible. Actually, 0 and 0, is that in the Sahara Desert? We'll go with that for now until somebody corrects me. So if I start here and I end up over there, we can go for the typical stunning visual effects. That is that's my change in position right there. That's my displacement. This is where I am relative to where I started. This is my final position, this is my initial position, and the change, the difference between the two is my displacement. And I think I commented before, yesterday or the day before, there are not a lot of times that you can really use the word always, but one of the times that you can use always is that change is always the final minus the initial. So change in widgets would be final widgets minus initial widgets. So for the sake of this exercise, I'm going to make this right here my starting point. Now I have to have the same convention. To the right is positive. So right now my position is, there wasn't much enthusiasm in that. My position is
positive.
There we go. My displacement?
Positive.
People seem unsure on that one.
Yeah.
Where am I relative to the starting point?
Positive.
Yeah, there we go. What is my displacement now?
Negative. 0.
0.
0. Right. And my position?
Positive.
Yep, I'm on the right side. I'm on the positive side of 0. I'm at my starting point. My position?
Negative.
And my displacement?
Negative.
Negative.
All right. Now, I believe it was Mark said that when I went from here to here and you said negative displacement, I assume it's because I moved this way. So let's get into sort of the understood words that aren't necessarily spoken. There are two types of displacement. There's the overall, and there is the instantaneous. So instantaneous is where am I relative to where I was just a moment ago. So in which case Mark would have been correct. And then there's the overall displacement is where am I relative to the start of the entire journey. And so by default, if I just say displacement, I'm talking about overall, not instantaneous. If I want the instantaneous displacement, I would have to use the word instantaneous. All right, questions here before I use some more vocabulary?
So what you did was overall displacement?
Yes,
Okay.
yes. Which is why my displacement here is 0, because I'm not, what I'm claiming is the starting point.
So what's instantaneous then?
If I move over here, I have positive displacement, and then I move back to here. Overall displacement is where I am my relative to my starting point.
Oh, okay.
My instantaneous displacement is where am I
Just
a fraction of a second before,
Okay.
which was here. So I have negative instantaneous displacement, but positive overall displacement.
Understand.
All right, these are vector terms. Let's introduce a scalar term. The analog of displacement is distance. So let's sort of lasso this. And the symbol for distance is pretty much the same as the vector analog of it, displacement, except for the fact that there are no vector symbols. So it's be delta x, delta s, etc. And this is not necessarily the magnitude of the displacement. So if I'm starting here and I go 5 meters to the right and then I go 3 meters back, the distance traveled, well, that's 8 meters, but my displacement is 2 meters to the right. That's my displacement. But the distance, 8 meters. Distance, unless you define something strangely, distance is always going to be a positive number. Negative distance, I guess you're going back in time. All right. So vocab word, velocity. And the symbol for velocity, they got clever with this one. V, with a vector symbol. There are two types, of course.
Is that still considered the scalar, under scalar or under vector?
So velocity, velocity is a vector. The scalar, since you bring it up, is speed. And the symbol for speed is V. Don't use S. Or R. So it's the two. The ones, just one.
So velocity is considered a vector because it involves direction.
Yes, absolutely.
And speed. Okay, I got it.
Yeah. You don't get a velocity ticket, you get a speeding ticket.
Yeah.
Because they don't care which direction you're going in.
All right. Great way to remember it.
All right, the two types, we have average and instantaneous. And the default is instantaneous. So if I ask for the velocity of an object, it's at that particular moment. If I want the average velocity, I need to specify average. So average velocity depends upon how long it's taken to get to where I am relative to my starting point. Average velocity is displacement divided by time. Instantaneous velocity deals with instantaneous displacement over time. In other words, what is the rate at which my position is changing? Or you could speed in a direction. So whether something velocity is positive or negative, and since I didn't put the adjective in front of it, assume instantaneous, if velocity is positive, negative, or zero, it depends on which way I'm moving. Right now I've got a positive velocity. Right now I have a negative velocity, even though my position is positive, now my position is negative. Questions before we do the next round of the game? All right, so I'm just gonna have to, since we're now at the three things, that could be a little bit faster. All right, my position,
Negative.
my displacement,
Negative.
my velocity.
Positive.
Yep. Let's see if we can get more than a couple of voices here. My velocity,
Zero.
Zero.
my displacement,
Negative.
my displacement,
Positive.
well,
Zero.
my velocity,
Positive.
my velocity.
Negative.
Okay. All those are pretty well straightforward. The biggest problem I see students make is they confuse position with displacement. And position cares about zero. So position and zero post office, or Ocean Pacific, or operation, or whatever you need to do. Displacement cares about starting point. Detective Sergeant, come up with your own memory trick. So if I'm traveling from here to Columbia, South Carolina, it's about 200 miles south of here. So if I go from Winston-Salem to Columbia, South Carolina, what will be my displacement when I get there?
200 miles.
Well, what do
Pardon?
you mean that? I don't know.
Negative, because you're heading down.
You're on the right track, but
That's-
you have to do something if you're gonna say negative. Almost there. All right, so the key thing that I didn't hear before was a direction. We have to somehow indicate direction. So if you're saying negative, what are you assuming?
You're going down or
Below your initial
you're
point.
going. If we're going based off the x-axis, you're going down, so negative.
So you're assuming that down is negative
South,
or up is positive.
so it would be south,
Sorry?
south,
South would eliminate all the confusion there. If you just said 200 miles south, that would have done it. If you want to say negative 200 miles, then you have to establish which the positive direction is. Positive is, if you want to say positive is north, then negative 200 miles works. Now, in reality, you can't just go straight, not in a car at least. So, I mean, there's turns and there's sightseeing and, there's wrong turns and so forth. So I looked at my odometer before and afterwards, and my odometer says that I went 500 miles. So what's my displacement?
200 miles.
So it's
200 miles, so.
Okay. What's the distance traveled?
About 100 miles.
All right. If it took me 4 hours, what is my average velocity?
Displacement over time.
That'd be louder,
Displacement over time.
okay? Which would mean,
50 miles south. Per hour.
okay,
I'm sorry.
south per hour. All right, so it's displacement, so 200 miles. Let's just make life convenient. I'm going to say that's positive, so negative over 4 hours. So negative 50 miles per hour. And what's my average speed?
50 mile an hour. 50
Nope.
mile an hour.
Under
Not 50 miles per
25
hour.
miles per hour?
Pardon?
Under 25 miles per hour?
Yes. The distance I traveled, 500 miles in 4 hours.
Oh, I see.
Just taking the absolute value, just saying it's 50 miles per hour, ignoring the direction, that only works if there are no turns. You travel in just one direction, so then the distance is just the magnitude of the displacement. Questions to hear? I'm in a race with Usain Bolt. We start here, and this is the start and the finish, going around. Let's just, for the sake of argument, assume Usain Bolt is faster than I am. So he goes around the track in 40 seconds. So 400 meters in 40 seconds.